All right, this is LeetCode 141. It's called linked list cycle. So given a head of a linked list, determine if the linked list has a cycle in it. And there's a cycle in the linked list if some node in the list can be reached again by continuously following the next pointer. Internally, pos is used to denote the index of the nodes that tail's next pointer is connected to. Note that pos is not passed as a parameter, and then return true if there's a cycle in the linked list, otherwise return false. Okay, so what they mean, let's look at an example. So here's our linked list, this is the head. If we keep traversing it, if you follow the arrows here, you see that this node here, its next value wraps around back to here, so it's basically there's a cycle. There's like a loop here, if it makes sense. If you would never finish looping if you kept just iterating through this linked list. And this is what we're supposed to detect and return true or false. So in this case, we return true because there's a cycle here. The 4 wraps around back to this node that we've seen before. This one we would also return true because there's a cycle. This one we return false because there's no cycle. Now, what would it look like when would we return false otherwise, not in like the test case of just having one node? Well, if this next wasn't there, if it was just pointed to none, then this would return false because there is no cycle. But that's not the case for this example, but that's kind of when we would return false. Okay, so how would we do this? Initially I thought maybe, and then actually down here in the constraints it says, follow up, can you solve it using O of 1 constant memory? So I think probably the brute force solution, this automatically makes me think of this array question where it contains a duplicate. Obviously there's no cycles in here, but there's no cycles in an array, I guess, right? You can't go back to the other one. But the brute force solution, I feel like, is like maybe we could have a set with the nodes that we've seen, and if we see another node that we've seen before, then we know that we've hit a duplicate, if that makes sense. That has like a caveat of maybe that I don't think we're guaranteed that every node's value is going to be distinct. And then that would take some memory. Okay, so how would we actually solve this otherwise then? I believe we can solve this using pointers. So let's say that we had some pointers. Let's say this is P1 and this is P2. So this is, in blue, is in the first iteration. And I think what we can do is we can just play almost like a game where these pointers are chasing each other, or this one's chasing this one, but this one is faster. This one can run twice as fast as this one. So basically what I mean is that when we iterate, this P1 is going to iterate always by 1 step, so it's always going to go 1. And then this P2 is going to iterate by 2 steps. So it's going to jump P2. So you can think of it as this P2 is a lot faster. It's twice as fast, so it can jump 2 spots compared to only P1 can jump 1 spot. This one can jump 2 spots. So here's our pointer there, right? And then if you see it now, let's do it in green. And now P1 is going to be here. That's not a very good color. Let's do it in it's not very different than the other colors. Do it in red. There's P1, and then let's say P2. This one's gonna, how much is it gonna jump by? 2, because it's faster than the other one, so it's gonna jump by 1, 2, and there we go. P1 and P2 are at the same value, or at the same node. So then we know that there's a cycle. So basically, the whole gist of this algorithm is we're gonna have 2 pointers that are gonna be iterating through the linked list, but one of them is gonna be going twice as fast as the other. Or iterating twice as many nodes as the other. So then eventually, if there is a cycle, then this node here, P2, is going to catch up to P1, and eventually they're going to be overlapping. Okay, so before we get into writing the code for this algorithm, let's find the time and space complexity, or let's talk that through. So, time complexity, I believe that would be O of n. O of n. Let me write this over here, actually. It's not in the way. I think the time would be O of n. So time, and then space would be constant, right? And this is what they're asking for us in the prompt. So I believe the time would be O of n because I think that in the worst case scenario, we would maybe we would have to loop through the entire linked list, right? So that's why we would have O of n, and then the space would be constant because this, we're only using 2 pointers. We're not storing any other memory. We're not storing a set of the nodes that we've seen. These two values here, P1 and P2, these pointers, they're always going to be constant. The amount of memory that we're going to use is going to be constant, no matter the size of this linked list, because we're only going to have two pointers to detect the cycle. Okay, so let's go ahead and try to write the code for this solution. So as we have on the picture on the left, we're going to have 2 pointers. So we're going to have P1 is equal to head, and then P2 is equal to head dot next. However, I think we have to do some a little bit of checking beforehand, because there's a possibility that we have 0 nodes in our linked list, or 1 node, all the way up to 10 to the 4th, as it says right here in the constraints. The number of nodes in the list is that many in that range. So I believe what we can say is if head equals none, then just return false, because in that instance P1 is going to be equal to none, and then this would be out of bounds, so we would get an error right away. So we can just return false. If there's no nodes in our linked list, then there's no cycle, right? This is basically if there's no nodes. There is no nodes, right? Okay. And then those line 11 and 12 should be fine now. And then what we're going to do is we're going to have a loop. We're going to say while P1 does not equal none, right? Because we want, in the instance where there isn't a cycle, we want P1 to go all the way to the end of to the last element, right? And then on the next iteration, it would go to none. Hopefully, in the instance where we have no cycle, right? And then that would be the end of our loop, and then we can just return false at the end of when we exit the loop, right? So while P1 does not equal none, and basically what I'm saying with that example is, in the scenario where we don't have this, where this is crossed out, right? This is just pointed to none. We want P1 to reach this last node, and then eventually it'll hit this node, and it's going to end this loop, so that our loop will end, right? Okay, and then inside this loop, we're going to say if P1 equals P2, the actual value, or the actual nodes themselves, not the values, because there's a possibility, it doesn't say that the nodes' values are distinct, right? So we could have a linked list with values of all ones, right? We can have all ones in these values, and we don't want to depend on just checking the values. Okay, so we want to check the actual nodes, not p1.value or p2.value. So this is what's going to detect if we have a cycle. If these pointers overlap, basically, if these pointers to nodes overlap, then we're going to say return true if we found a cycle, right? Okay, and now what we have to do is we have to move our pointer. So p1 is equal to p1.next. That's fine. But we have to do something special for p2 because it's moving twice as fast, right? In this picture, p2 moves like twice as fast as the other pointer, right? It's twice as fast as p1. What we have to do is to make sure we don't get an index out of bounds or an index out of bounds error, then we need to make sure if p2 does not equal none, then we could say p2.next, or p2 is equal to p2.next. And then what we're going to do is we want to iterate it one more time, so we're going to do the same thing. It's not equal to none. Then p2 is equal to p2.next. There we go. We've done our iterations. Oops. Cool. And then this should be fine. This loop should end. And then if we get out of the loop, then we can just return false, right? The indentation of this is just out of the loop. This is an instance of we had a normal linked list with no cycle. Then we return false. Yeah, I think that's that. Let me see if I don't know if I made any errors, but I guess we'll find out right now. Invalid syntax for this, right? I didn't put if. Cool, that's that. So yeah, I believe, like I said before, this is the time and space complexity. And yeah, this satisfies what they're asking for. We're using constant memory because these two pointers are always going to stay constant no matter the size of this linked list. This linked list could be 1,000 nodes long or 10,000 nodes long, and we're only going to have two variables to try to detect that list. It's not going to grow as our input size grows. So yeah, it's a pretty good space complexity for the solution. Cool.